if the job is to factor this fifth degree polynomial, 10y to the fifth plus 26y to the fourth minus 12y to the third, what's your process? What's your list of steps? What was your approach? What did you do first in this problem?
GCF.
Yeah. As we talked about in the previous module, that is always a good first step. Identify and factor out the GCF. So what is the GCF of this, the greatest common factor of this set of three terms, 10y to the fifth, 26y to the fourth, and 12y to the third? So the greatest common factor of their coefficients is 2. What about the greatest common factor of the monomial powers of y? What else besides 2 do these three terms share in common?
Y3?
Yeah, y to the power 3. So don't leave the powers of your variable out of the GCF process. They're at the table in that discussion. Y to the third is a factor in 12y to the third, clearly, but it's also a factor in 26y to the fourth, because 26y to the fourth is 26y to the third times y. We can break apart the y to the fourth into a y to the third times a y to the first. Likewise with the y to the fifth is y to the third times y squared. So y to the third is a factor there as well. So the greatest common factor is always the best first step in any factorization problem, because it can turn what looks like an intractable problem into one that we can actually do. After all, we didn't talk about any techniques for factoring fifth order polynomials. But we did talk about techniques for factor second order polynomials. So if we're able to get a second order polynomial out of this factorization, then we'll know what to do. So let's do the factorization. If I bring 2y to the third out of this expression, what do I have left over? 5y squared. So the 5 coming from 10 divided by 2, and the y squared coming from y to the fifth divided by y to the third. Subtract the exponents. 26y to the fourth, when we take 2y third out, becomes 13y. And the 12 minus 12y to the third, 6. Great. So we factored out the greatest common factor. And now that greatest common factor lives out here in the front of our factorization problem, and we never touch it again. It just comes along for the ride. And we can focus our attention completely on what's written up here in orange. 5y squared plus 13y minus 6. And now the task is to factor that thing. And here is where the fun comes in. What techniques do we have to factor a trinomial that looks like that? What did you try, Robert?
I would multiply the 5 and the 6.
All right. So this is setting up what your book calls the AC method. AC, quote unquote. A referring to the coefficient of the quadratic term, C referring to the coefficient of the constant term. And if we multiply the two of those together, what did you get?
30.
All right. AC is equal to 30. Now what did you do with that number?
I found two numbers that multiply into.
So the AC method works by using that number, A times C, as your target product for what you're trying to find two numbers that multiply together to give you. Now, I'm going to just only slightly modify that to say that C should have been really negative 6 instead of 6. So AC,
So would it be negative 30?
I would say AC would be negative 30 in this example, just to make sure that we have our signs straight and we don't have to fiddle around with them later. So you're right. We need two numbers which multiply together to give you negative 30, and which add together to give you how much? 13. That's our original middle term. It's the only difference between this and the plain vanilla trinomial factorization method, is that instead of just looking at the 6 and the 13 for your sum and product, for your product you look at the product of A and C, which is minus 30. The sum still has to be 13. This is a neat method. It's almost like a miracle that it works. So when we do that search, what pair of numbers fit this bill?
3 and 10.
3 and 10 are enough to get us a 30. And if they have to add together, 3 and 10, So those multiply together to give me positive 30, though. So 3 and 10, we know that one of them needs to be negative in order to multiply together to give us negative 30. If I make the 3 negative, then these are going to add together not to give me 13, but they're going to give me 7. Right? So that doesn't quite work. If I make the 10 negative instead, then all that does is give me negative 7 for the sum.
So what do we do with the negative 30?
So the negative 30, we're still doing the same thing with. We're trying to split it into a pair of factors. But we have a lot of options to pick from. 15 and 2, 10 and 3, 5 and 6. And then after that, I think we start repeating ourselves. 6 and 5, 3 and 10, 2 and 15, 1 and 30. And since the product needs to be negative, that means that these pairs have to be mixed sign pairs. One of them has got to be negative and the other's got to be positive. So let's put negatives here in front of these lists. Yeah, there we go. So we're looking for the pair here which adds together to give us positive 13. Since the sum needs to be positive, that means that the larger of the two numbers in my sum needs to be positive. So I'm going to choose the pair right here. Negative 2 and 15. Negative 2 and 15 is the winner in our little AC sum and product game. Right? It multiplies together to give us negative 30. It adds together to give us positive 13. So now that we have our numbers, negative 2 and 15, what do we do with them? Parentheses.
Wait, the 2y to the third would be in the front?
Yeah, the 2y to the third remains in the front. We're not even going to deal with it ever again, except to write it in our final answer.
Parentheses y minus 2, parentheses 5y plus 15.
So let's check that. If we multiply these together, we'll get 5y squared plus 15y minus 10y is going to give me plus 5y, not the plus 13y I'm looking for. So here's the other difference with the AC factorization method. Is what it does is it actually gives you a clue as to how to factor this by grouping. And what that means is that means that it gives us a hint as to how to break apart those 13 y's that we have here in the middle into a sum of two different terms in such a way that the first pair of terms and the second pair of terms are going to have a common factor that we can bring out. So let me expand on what I mean by that. So we've identified negative 2 and positive 15 as how we want to break apart the number 13. So there are two possible ways to do that then. Write it as minus 2y plus 15y. That's the first option, and if I do that and put the rest of my expression into context here, what I'm looking for is something which will let me factor out of this pair of terms and out of that pair of terms something that they share in common. Let's take a look at what that might be. So certainly in the first pair of terms, y is the greatest common factor. So we'll factor that out. If I factor a y out of that first pair of terms, what's left over? Y out of 5y squared? Leaves me with just 5y. Y out of negative 2y, yeah, leaves me with minus 2. Now let's look at that second pair of terms. What can I factor out of 15y minus 6? What does that have in common? It's got a 3. And if I bring that 3 out, let's say plus 3, then what do I have left inside those parentheses? 3 out of 15y? Yeah, and 3 out of minus 6. So there's the magic of this AC method, is that when I've split that middle term into this two pieces, I can then, what's called factor by grouping. I can bring a factor out of the first pair of terms, the greatest common factor out of the first pair of terms, and I can bring the greatest common factor out of the second pair of terms. And even though those greatest common factors are different, the cofactor that's left over remains the same. 5y minus 2 here, 5y minus 2 there.
You remove the 5y and 2.
Yeah, and so that's our last step then, is that the 5y minus 2 is then factored out of this expression.
So y plus 3.
Yes. Let me write it this way. So we're going to factor something out, but the 5y minus 2, we're going to write it only once. 5y minus 2. And when I factor that 5y minus 2 out, the cofactor is just going to be that stuff which is left over.
Plus 3.
Y plus 3. So when all of the dust finally settles, the only thing I haven't written in my final answer is that 2y to the third that we said we wouldn't pay attention to for a while. Don't forget it. That's another common mistake in doing these multiple step factor problems. Just, it was there in the beginning and it needs to be there in the end, even if you end up doing a bunch of other stuff in the middle. But there's a complete factorization of this polynomial.